January 1945. A mud-spattered olive-drab vehicle sits in a heated workshop at the Wehrmacht testing facility in Kummersdorf, south of Berlin. Senior automotive engineer Hauptmann Klaus Müller circles it slowly, notebook in hand, while his team prepares their tools and measurement instruments. This isn't the first American vehicle they've examined. They've studied captured trucks, half-tracks, even a Sherman tank. But this one is different. This small, simple-looking utility vehicle has appeared everywhere American forces operate, from the deserts of North Africa to the hedgerows of Normandy to the frozen forests of the Ardennes. The Americans call it a Jeep, though official documentation lists it as truck, 1/4 ton, 4x4. German frontline reports mention it constantly. American reconnaissance uses them. Their infantry officers ride in them. Their artillery observers direct fire from them. Supply units swarm with them. They're ubiquitous, seemingly indestructible, and maddeningly effective. What Müller and his team are about to discover will explain something that has puzzled German commanders since 1942. How do American units maintain operational tempo that German forces cannot match? How do they maneuver faster, resupply quicker, and maintain communication more reliably than Wehrmacht units with comparable personnel strength? The answer is parked in front of them, weighing just over 1,000 kilograms. The capture. The specific vehicle in Kummersdorf arrived via an unusual route. On December 20, 1944, during the desperate final push of Operation Wacht am Rhein, the Battle of the Bulge, elements of the 12th SS Panzer Division overran an American communications outpost near Malmedy. Among the captured equipment were 3 jeeps, 2 still operational, 1 damaged by small arms fire. The divisional commander, recognizing standing orders to forward captured enemy equipment for technical evaluation, had the 2 functional jeeps sent rearward immediately. One went to a field workshop for immediate use by German forces. Captured American vehicles were prized for their reliability and fuel efficiency compared to German equivalents. The other was tagged for technical intelligence and shipped to Kummersdorf. It arrived on January 3, 1945, still bearing the tactical markings of the U.S. 7th Armored Division. Someone had painted a hasty Bockenkreuz on the hood, the German cross identifying it to Luftwaffe pilots as friendly. Müller ordered it washed but not restored, wanting to examine it in as-found condition. Now, on a gray January morning with snow falling outside the workshop, he begins his analysis. First impressions. Müller walks around the Jeep slowly, making initial observations. His first notes focus on dimensions and weight. The vehicle is remarkably small. Length, approximately 3.3 meters. Width, 1.6 meters. Height with windshield folded, barely 1.3 meters. Ground clearance, an impressive 22 centimeters. The wheelbase is just 2 meters, incredibly short for a 4-wheel vehicle. His assistant, Unteroffizier Ernst Schneider, a former automotive mechanic drafted into technical service after losing his left leg below the knee at Kursk, performs the weight measurement. They drive the Jeep onto a calibrated scale. 1,040 kilograms, Herr Hauptmann, Schneider reports. Empty, no fuel, no cargo. Müller writes this down, then retrieves his file on the Volkswagen Kübelwagen Type 82, Germany's closest equivalent to the Jeep. The Kübelwagen weighs 725 kilograms empty, significantly lighter. But Müller knows from field reports that the vehicles are not comparable in capability. The Kübelwagen is rear-wheel drive with limited ground clearance. The Jeep is 4-wheel drive and can traverse terrain the Kübelwagen cannot. A better comparison might be the Steyr 1500A, Germany's light cross-country vehicle. But that vehicle weighs 1,800 kilograms empty and requires significantly more resources to produce. The Jeep falls precisely between Germany's 2 vehicle classes, more capable than the Kübelwagen, lighter and simpler than the Steyr. Oberstfreiter Hans Dietrich, the team's materials specialist, examines the body construction. He taps the hood with a knuckle, then the fender, then the body panels. Sheet steel, Herr Hauptmann. Pressed and formed. Very simple construction. He points to the hood. This entire panel is a single stamping. The fenders, stamped as well, then welded to the frame. No complex forming, no hand fitting. A hydraulic press could make hundreds per day. This catches Müller's attention. He examines the body panels more closely. The American manufacturing philosophy is evident immediately. Nothing is made to higher standard than necessary. The hood fits adequately but not perfectly. There are small gaps between panels. The paint is applied functionally but not beautifully. There are runs and slight imperfections that would never pass German quality inspection. Yet the vehicle clearly works. The captured Jeep shows hard use. Mud still caked in crevices, scratches on the paint, a small dent in the tailgate, but it drove into the workshop under its own power without hesitation. Simple construction, adequate quality, maximum production, Muller mutters, writing in his notebook. It's the same philosophy they observed in American rifles, now applied to vehicles. They lift the Jeep on a hydraulic platform to examine the undercarriage. What Muller sees is simultaneously crude and brilliant. The frame is channel steel, welded together in a simple ladder configuration. There are two main rails running front to rear with cross members connecting them. The construction is straightforward. No complex curves, no sophisticated engineering. A competent welder could fabricate this frame in a few hours. But it's robust. The frame rails are substantial, and the cross members are positioned to distribute stress effectively. Dietrich measures the thickness, 3 mm on the frame rails, slightly thinner on the cross members. They've overbuilt it, Dietrich observes. This frame could probably support twice the vehicle's weight. They've added material to compensate for less precision in manufacturing. Muller nods. It's an approach that only works if you have abundant steel production and aren't concerned about saving every kilogram. Germany must optimize every design for material efficiency. America apparently doesn't face that constraint. The suspension is equally simple. Leaf springs at all four corners, the most basic suspension design possible. Schneider, who worked on passenger cars before the war, points this out. Herr Hauptmann, this is practically agricultural equipment design. Leaf springs, simple shackles, basic shock absorbers. A luxury car from 1930 would have more sophisticated suspension. Yet the leaf springs are long and well configured. The spring rate appears carefully chosen to balance load capacity with ride quality. Muller examines the shackles that mount the springs to the frame. Simple pins and bushings, easily replaceable. How long would it take to replace a spring? Less. Schneider considers. With basic tools? Perhaps 20 minutes. You remove 4 bolts, disconnect the shock absorber, pull the pins, and lift out the spring. Any mechanic could do it, even in field conditions. Compare this to German military vehicles with more sophisticated suspension systems requiring specialized tools and trained mechanics. The Jeep's simplicity is a strategic advantage. Repairs can happen at the front line, not in rear area workshops. The team examines the axles next. Both front and rear are solid beam axles with open differentials. They're robust, seemingly overbuilt like the frame. The differential housings are cast iron, simple in design, with drain and fill plugs easily accessible. 4-wheel drive, Schneider notes, tracing the drive line with his finger. Transfer case here, drive shaft to the front, drive shaft to the rear. The front axle has these locking hubs. Muller photographs the transfer case, a compact unit mounted behind the transmission. It's stamped with manufacturer markings, Spicer Model 18. He makes notes about the shift pattern. There's a small lever inside the vehicle allowing the driver to select 2-wheel drive, 4-wheel drive, or 4-wheel drive with low-range gearing. This is a critical capability. The Kübelwagen cannot match this. In mud, sand, or snow, the Jeep can power all 4 wheels and use low-range gearing to maximize traction. The tactical advantage is obvious. American reconnaissance and supply vehicles can traverse terrain that would stop German equivalents. The engine. On the second day of examination, they focus on the power plant. Schneider removes the hood and they gather around the engine bay. The engine is small, compact, and remarkably simple. A cast iron block with willys cast into the side. 4 cylinders in inline configuration. Displacement, according to measurements, approximately 2.2 liters. An L-head design with side valves rather than overhead valves. This engine is antiquated, Schneider says bluntly. Side valves? This is 1920s technology. German engines abandoned this design years ago for overhead valve designs that produce more power and efficiency. Yet Muller sees advantages. Side valve engines are simpler to manufacture. Fewer parts. Less precision required. The valve train consists of a single camshaft in the block operating pushrods directly against the valves. No rocker arms. No overhead components. Fewer things to break. They start the engine. It catches immediately despite sitting cold in an unheated workshop. The idle is rough compared to German engines. There's vibration and noise, but it runs steadily. Schneider checks the oil pressure gauge on the dash. Normal. Temperature rising normally. Muller increases the throttle. The engine responds without hesitation, revving smoothly to what he estimates is 3,000 revolutions per minute. The governor limits it there. He notes that the engine sounds agricultural. There's mechanical noise that would be unacceptable in a German military vehicle, but it runs without missing or stumbling. They let it run for 30 minutes, monitoring temperature, oil pressure, and listening for any irregularities. The engine settles into a steady rhythm, maintaining temperature in the normal range, showing no signs of distress. Dietrich examines the engine specifications stamped on a small plate, Go Devil 441. Later research in captured American technical manuals reveals the specifications: 60 horsepower at 4,000 revolutions per minute, torque of 105 pound-feet at 2,000 revolutions per minute. Muller does quick calculations. 60 horsepower moving 1,040 kilograms yields a power-to-weight ratio of approximately 58 horsepower per ton. This is adequate but not impressive. The Kübelwagen with its 25 horsepower engine produces only 34 horsepower per ton, but the Steyr 1500A produces 55 horsepower per ton. Yet field reports consistently indicate the Jeep outperforms German equivalents in cross-country mobility. The power-to-weight ratio doesn't fully explain its effectiveness. Something else is at work. Driving tests. On day 3, they transport the Jeep to the proving ground for dynamic testing. Muller drives first, wanting personal experience with the vehicle's characteristics. The driving position is Spartan. A simple bench seat with minimal padding. No doors, just openings with a canvas covering rolled up and tied to the side. The windshield folds down flat against the hood. Weather protection is essentially non-existent. German military vehicles typically provide enclosed cabs, weather protection, some basic comfort for crews. This vehicle offers none of that. It's utterly utilitarian. Yet when Muller turns the ignition key and presses the starter button, the engine catches immediately. The clutch pedal is heavy but progressive. He shifts into first gear. The transmission is a 3-speed manual with a floor-mounted shifter and releases the clutch. The Jeep moves forward smoothly. Muller drives it around the proving ground at moderate speed, getting a feel for the controls. The steering is direct and responsive, much more so than German trucks. The turning radius is remarkably tight. He can execute a U-turn in perhaps 5 meters of width. The suspension is firm, transmitting road texture directly to the chassis. In a German staff car, this would be considered unacceptably harsh. But Muller realizes this isn't designed for comfort. It's designed for control and feedback. The driver can feel exactly what the wheels are doing. He accelerates harder. The engine revs willingly. The Jeep reaches 50 kilometers per hour quickly, then 60, then 70. At 80 kilometers per hour, the engine is working hard and wind buffets the open cabin. Muller estimates top speed around 90 to 95 kilometers per hour, adequate for a utility vehicle. But it's off-road where the Jeep reveals its true character. Muller drives to the rough terrain section of the proving ground, a course with ditches, mud pits, steep inclines, and loose surfaces designed to test military vehicle capability. He shifts the transfer case into 4-wheel drive and low range. The difference is immediate. In low range, the Jeep crawls up a steep embankment with the engine barely above idle. All 4 wheels claw at the dirt, maintaining steady progress up a slope that Muller estimates at 35 degrees. The Kübelwagen would never attempt this. It would spin its rear wheels and slide backward. He drives through a mud pit. The Jeep splashes through, all 4 wheels driving, never losing momentum. The high ground clearance keeps the chassis above the mire while the 4-wheel drive maintains traction. At a ditch approximately 1 meter wide and half a meter deep, Muller accelerates slightly and drives in without hesitation. The short wheelbase means only one axle at a time is unsupported. The front wheels drop into the ditch, then climb the far side. The rear follows. The Jeep bounces through roughly but never grounds out, never loses traction. Schneider drives next. As a former mechanic and current vehicle specialist, he pays attention to different details. Herr Hauptmann, notice the control response, he calls out while navigating rough terrain. The steering is immediate. The throttle response is quick. The brake pedal has good feel. For a driver trying to maintain speed over rough ground, this is ideal. You can make constant small corrections without delay. This is a critical observation. German trucks often have slack in the steering, delay in throttle response, brakes that require careful modulation. The Jeep feels like a sports car by comparison. Everything responds instantly to driver input. Schneider attempts the same obstacles Muller traversed, then finds more challenging terrain. He drives the Jeep up a rocky incline with loose gravel, wheels scrabbling for traction but maintaining forward progress. He backs down a steep slope, demonstrating the low-range gearing provides excellent control in both directions. After 2 hours of testing, Schneider returns to the workshop. He shuts down the engine and turns to Muller with an expression of reluctant admiration. "This vehicle will go anywhere," he says simply. "Terrain that would stop our trucks, terrain that would challenge our half-tracks, this just drives through. And any soldier with basic training could drive it. There's nothing complicated, nothing that requires special skill." Manufacturing analysis. On day 4, they begin systematic disassembly. This is where the Jeep's true genius reveals itself. Dietrich, as materials specialist, catalogs every component. He groups them by manufacturing method: castings, forgings, stampings, machined parts, welded assemblies. The pattern becomes clear quickly. The Americans have minimized machining and maximized simpler manufacturing methods. The body panels are all stampings. A large hydraulic press with dies could produce complete fenders, hoods, body panels in seconds. No hand-forming required. The panels are then welded together, spot welding primarily, which is fast and requires minimal skill. The frame is welded channel steel. Cut to length, positioned in a jig, welded together. A semi-skilled worker could produce several frames per day. The axles use castings for the differential housings and simple machined gears inside. The castings are rough but adequate. The gears are cut with standard equipment. The engine block is a simple casting with minimal machining. The cylinder bores are machined, the deck is surfaced, the main bearing journals are cut, but there's no complex machining work. The crankshaft is a forging, machined to final dimensions but of straightforward design. Dietrich counts the parts requiring precision machining. Compared to a German equivalent vehicle, the number is perhaps half. Everything else is cast, forged, stamped, or welded, processes that can be performed by less skilled workers with less sophisticated equipment. They've designed this entire vehicle for mass production, Dietrich concludes. Every design decision prioritizes manufacturability over performance optimization. The result is a vehicle that's simple enough for American industry to produce in enormous quantities. Muller asks the critical question, how many could they build? Dietrich considers the simplicity of design, the minimal machining required, the stamped body panels. A well-organized factory could probably produce hundreds per day, perhaps thousands per day if they set up multiple production lines. This number seems impossible. Muller asks him to verify. Dietrich examines the vehicle identification plate. It shows a serial number and a manufacturer, Willys Overland, Toledo, Ohio. But they have intelligence reports indicating multiple manufacturers produce Jeeps. Ford Motor Company is known to produce an identical vehicle. If multiple factories, each with high production rates, are building Jeeps, Muller does the mathematics. Thousands per week, tens of thousands per month. The numbers become staggering. Maintenance philosophy. Schneider focuses on maintenance and repair. He approaches this from a mechanic's perspective. What breaks? How do you fix it? What tools and skills are required? He identifies the wear items, components that will need regular replacement. Oil and filters, spark plugs, brake shoes, tires, belts. For each item, he evaluates the replacement procedure. Oil change, drain plug at the bottom of the oil pan, easily accessible. Remove drain plug, drain oil, replace filter, a spin-on canister that requires no tools except hand strength. Refill. Total time, 15 minutes. Spark plugs, 4 plugs accessible from the side of the engine. Remove spark plug wire, unscrew plug with a standard socket wrench, install new plug, reconnect wire. Time per plug, 2 minutes. Total time for all 4, less than 10 minutes. Brake shoes, remove wheel, remove drum, remove old shoes, install new shoes, replace drum, replace wheel. Standard procedure, but the simplicity of the brake design makes it straightforward. Time per wheel, 30 minutes for an experienced mechanic, perhaps an hour for a trained soldier with basic tools. For every maintenance item, the procedure is simple and the required tools are minimal. A basic tool kit, wrenches, screwdrivers, pliers, a few sockets, can perform nearly all routine maintenance. Schneider finds the technical manual in a canvas pouch strapped under the passenger seat. It's a U.S. Army publication, TM 9-803, 1/4 ton 4x4 truck, Willys Overland Model MB and Ford Model GPW. He pages through it with increasing amazement. The manual is written for soldiers, not mechanics. Everything is explained in simple language with clear illustrations. Maintenance procedures are broken into step-by-step instructions. Troubleshooting guides help diagnose problems systematically. There's a section on organizational maintenance, repairs that can be performed by unit-level personnel with basic tools. Then field maintenance, more complex repairs requiring specialized tools. Then depot maintenance, major overhauls requiring workshop facilities. The philosophy is clear. Push as much maintenance as possible to the lowest level. Keep vehicles operational in the field. Only send them to rear area facilities for major work. German maintenance philosophy is different. Most repairs require trained mechanics with proper tools in workshop facilities. This creates bottlenecks. Vehicles await repair in depot. Units operate with reduced vehicle availability. The American approach maintains higher operational availability. A battalion maintenance section can keep jeeps running in the field. Downtime is minimized. Schneider shows Muller a section of the manual covering emergency repairs. It describes field expedient fixes using improvised materials. How to patch a damaged fuel tank with soap and cloth. How to replace a broken fan belt with wire. How to repair electrical shorts with tape. They expect soldiers to keep these vehicles running under any circumstances, Schneider says. The manual literally tells them how to make battlefield repairs with whatever materials are available. This isn't engineering, it's survival philosophy. Strategic implications. By day 5, Muller begins writing his report. He has all the technical data, the test results, the analysis. But the report must go beyond description. It must explain why this vehicle matters strategically. He begins with production numbers. Intelligence reports indicate American Jeep production exceeds 50,000 units per month. By early 1945, total production likely exceeds 600,000 vehicles. The number is almost incomprehensible. Germany's total production of Kübelwagen from 1940 to 1945 will reach approximately 50,000 units, roughly what America produces in a single month. This disparity in production creates a fundamental imbalance in mobility. American units have vehicles available for every function: reconnaissance, command and control, liaison, supply delivery, medical evacuation, wire laying, weapons transport. Every task has dedicated vehicles. German units still depend heavily on horses. Intelligence estimates suggest 80% of German logistics uses horse-drawn transport. Horses require fodder, rest, veterinary care. They move slowly, perhaps 5 kilometers per hour for sustained movement. They cannot operate continuously. The Jeep can drive 20 to 30 kilometers per hour cross-country, faster on roads. It can operate continuously with only refueling stops. It doesn't require rest or fodder. This creates a fundamental difference in operational tempo. Muller develops scenarios to illustrate the impact. Scenario 1. Reconnaissance. A German reconnaissance patrol uses motorcycles and Kübelwagens to scout enemy positions 40 kilometers away. The patrol takes 3 to 4 hours to reach the objective area over rough roads. The Kübelwagen, limited to two-wheel drive, must carefully route around soft ground and steep terrain. An American reconnaissance patrol in Jeeps covers the same distance in 2 hours. The four-wheel drive capability allows direct routes across country. Upon contact with enemy forces, the Jeeps can maneuver aggressively, using terrain the Kübelwagen cannot traverse. The American patrol reports enemy positions twice as fast. American commanders have current intelligence while German commanders work with outdated information. Scenario 2. Artillery support. A German artillery battery receives a fire mission. The forward observer is located 5 kilometers from the battery position. He must relay coordinates via radio or dispatch a motorcycle courier. The motorcycle takes 15 to 20 minutes to traverse rough roads to the battery, deliver the fire mission, and return with confirmation. An American artillery observer operates from a Jeep equipped with a radio. He calls fire missions directly to the battery. The battery responds within minutes. When fire adjustments are needed, the observer communicates in real time. The American artillery can respond to targets of opportunity immediately. German artillery is always several minutes behind. Scenario 3. Supply delivery. A German infantry company dug in 10 kilometers behind the front requires ammunition resupply. Horse-drawn wagons are loaded at the supply depot and begin the journey forward. Travel time, 3 to 4 hours depending on road conditions. The wagons must follow established roads because they cannot traverse rough terrain. An American infantry company in the same situation receives ammunition via Jeep convoy. Each Jeep can carry 300 to 400 kilograms of ammunition in addition to crew. The convoy drives cross-country, taking the most direct route. Travel time, 30 to 40 minutes. The American company receives resupply 8 times faster. This allows higher ammunition expenditure rates, more aggressive operations, greater flexibility. Mueller includes these scenarios in his report because they illustrate the cumulative effect. Each individual advantage is small, a few hours here, a few kilometers there. But these small advantages occur thousands of times daily across an entire army. An American division has perhaps 1,500 Jeeps and comparable numbers of larger trucks. A German division has a few hundred vehicles and thousands of horses. When both divisions attempt to maneuver, resupply, coordinate artillery, evacuate wounded, and maintain communication, the American division does all of it faster. This speed differential compounds. The American division can complete a maneuver and resupply cycle in the time the German division completes just the maneuver. The Americans can launch an attack, resupply, and launch another attack while German forces are still preparing their first attack. Tactical flexibility. Mueller analyzes specific tactical advantages the Jeep provides. Command and control. American officers from platoon leader to division commander use Jeeps for transportation. This allows them to move rapidly around the battlefield, personally assess situations, make decisions based on direct observation. German officers often walk or use motorcycles. A regimental commander visiting battalion positions must take significant time to travel. An American regimental commander can visit all battalions in his sector in an hour or two. Better command mobility means better battlefield awareness, faster decision-making, more responsive leadership. Medical evacuation. Jeeps equipped with litter racks can evacuate wounded soldiers quickly from frontline positions to aid stations. 4 litters can be mounted on a Jeep, 2 on the hood, 2 over the rear. German medical evacuation relies heavily on stretcher bearers carrying wounded to collection points, then horse-drawn ambulances moving them to aid stations. The process is slow. Faster evacuation means more wounded soldiers survive. American soldiers know that injury likely means quick evacuation and good medical care. This supports morale. Communication. Jeeps frequently carry radio equipment, creating mobile communication nodes. An American battalion can establish radio communication anywhere its Jeeps can drive. German communication often relies on wire lines that must be laid by hand and are vulnerable to artillery fire. Wireless communication exists, but radio equipment is less available. Mobile communication means American commanders maintain contact with subordinate units even during fluid operations. German commanders frequently lose contact with forward units. Weapons platforms. Jeeps mount various weapons. The most common is the .30 caliber machine gun on a pedestal mount. Some mount .50 caliber heavy machine guns. Others carry 57mm recoilless rifles or bazookas. This creates mobile firepower that can rapidly reposition. An American reconnaissance unit with Jeep-mounted machine guns has firepower equivalent to a German infantry platoon, but with vastly superior mobility. Mueller understands that analyzing the Jeep in isolation misses the broader point. The vehicle itself is competent but not extraordinary. What's extraordinary is the industrial system that produces it. He researches American manufacturing. The Jeep is produced by 2 primary manufacturers, Willys Overland and Ford, but components come from hundreds of suppliers. Engines from one facility, transmissions from another, axles from a third. Each component is standardized, interchangeable between manufacturers. This distributed production creates resilience. Bombing one factory doesn't stop production, other facilities continue. It also creates economies of scale. Specialized facilities produce single components in enormous quantities, driving down costs and improving quality through repetition. German production is less distributed. Bombing a key factory can halt production of entire vehicle types. Specialized components often come from single sources, creating vulnerability. American factories employ mass production techniques pioneered by Henry Ford decades earlier. Assembly lines move vehicles through workstations where workers perform repetitive tasks. Each worker becomes highly efficient at their specific task. German production still involves more hand-fitting and skilled labor. Vehicles are assembled in static positions with workers moving to the vehicle. This requires more skilled workers and produces fewer vehicles per day. The Jeep is designed for American manufacturing strengths. Simple components that can be stamped, cast, or forged in high volumes. Minimal precision machining. Loose tolerances that don't require careful fitting. This allows semi-skilled workers to produce vehicles quickly. German vehicles are designed to German manufacturing traditions, precision, quality, performance. This requires skilled workers and more time per vehicle. When Germany needs 50,000 vehicles, this approach works. When America needs 600,000 vehicles, only their approach works. Schneider contributes analysis of fuel consumption and logistics. The Jeep averages approximately 15 liters per 100 kilometers, not particularly fuel efficient by civilian standards, but the small engine and lightweight design make it more efficient than larger military vehicles. More importantly, the Jeep uses standard gasoline. American logistics provides abundant fuel supplies. Every American unit has access to fuel dumps, fuel trucks, jerrycans of spare fuel. German logistics in 1945 struggles to provide adequate fuel. The Kübelwagen is actually more fuel efficient than the Jeep, but fuel shortages limit its operational range anyway. But there's a deeper issue. The Jeep's operational range enables American logistics strategy. An American supply system works like this. Fuel and ammunition are transported from ports to forward supply depots using large trucks. From supply depots to battalion positions using medium trucks. From battalion to company positions using Jeeps. This creates a layered system where vehicles of appropriate size serve each level. The Jeep is ideal for the final leg, small enough to navigate forward positions, capable enough to traverse rough terrain, sufficient payload to deliver meaningful supplies. German logistics uses similar principles but with horses providing the final leg of supply. Horses move at walking pace. They require fodder that must also be transported forward. In winter conditions, horses suffer from cold and require more care. The Jeep operates in any weather, requires only gasoline, and moves 5 times faster than horses. This fundamental difference in the final mile of logistics creates the operational tempo gap. The report's conclusion. Mueller spends day 6 finalizing his report. The document spans 47 pages with technical diagrams, photographs, comparison tables, and tactical analysis. His conclusion is stark. The American Jeep represents not merely a superior vehicle, but a superior system of military organization. The vehicle itself is simple, even crude by German engineering standards. Its power is adequate but not impressive. Its construction is utilitarian to the point of being Spartan. Yet the Jeep enables American forces to operate at a tempo German forces cannot match. The combination of four-wheel drive capability, simple maintenance, reliable operation, and overwhelming production numbers creates a mobility advantage that compensates for other American weaknesses. More critically, the Jeep reveals American strategic thinking. They have designed a vehicle that can be produced in enormous quantities using semi-skilled labor, can be maintained in field conditions by soldiers with minimal training, provides sufficient capability for 90% of light vehicle requirements, uses standardized components allowing distributed production. This is not engineering for optimal performance. This is engineering for total war, accepting adequate performance to enable mass production and easy maintenance. Germany cannot produce a comparable vehicle in sufficient numbers to matter. Our industrial capacity, even if undamaged by bombing, could not match American production rates. Our resource limitations prevent the scale of motorization American forces achieve. More fundamentally, our military organization is not structured to employ vehicles at American scales. Our logistics depend on horses and rail transport. Converting to full motorization would require not just vehicles but reorganization of supply systems, training of drivers and mechanics, establishment of fuel distribution networks, and stockpiling of spare parts. The Wehrmacht in 1945 cannot accomplish this transformation. The industrial damage, resource shortages, and strategic situation make it impossible. Therefore, German forces must continue operations with inferior mobility. This inferior mobility creates cascading disadvantages. Slower reconnaissance and intelligence gathering, delayed command response to battlefield developments, reduced artillery responsiveness, lower logistics, and resupply, reduced tactical flexibility. These disadvantages are not insurmountable in individual engagements, but they compound across thousands of daily operations. American forces consistently maneuver faster, resupply quicker, and maintain better communication. Over time, these small advantages accumulate into decisive superiority. The Jeep itself did not win the war for America, but it symbolizes the American approach to warfare, leveraging industrial capacity to create overwhelming material superiority, designing for predictability and maintainability rather than theoretical perfection, and organizing military forces to exploit these material advantages. Germany cannot replicate this approach. We can document it, analyze it, and understand it, but we cannot match it. Müller signs and dates the report, January 11, 1945. He submits it through channels to the Waffenamt, the German Army Weapons Office. The report circulates through German military technical services, but like similar analyses of American equipment, it arrives too late to influence anything. By January 1945, Germany is fighting for survival. There's no capacity for developing new vehicles, reorganizing logistics, or matching American motorization. Some German commanders read the report and recognize truths they've observed in the field. American forces move faster, respond quicker, sustain operations longer. The Jeep is part of that advantage. After Germany's surrender, American technical intelligence teams find Müller's report in the Waffenamt archives. They translate it with interest. The report confirms what American planners believed. The Jeep provides genuine tactical advantage. One American logistics officer, reviewing the translation, notes in his diary, "The Germans understood exactly what the Jeep gave us. They just couldn't do anything about it. That's what happens when you fight America. We're not smarter or better, we just have more of everything and we're pretty good at using it." Post-war, the Jeep's influence spreads globally. The vehicle becomes iconic, representing American military capability. Surplus Jeeps flood the world market. They appear in every continent, used by militaries, farmers, adventurers. Multiple nations develop their own versions. Britain produces the Land Rover, inspired by Jeeps left behind after the war. France develops the Citroën Mihari. Japan produces the Toyota Land Cruiser. The Soviet Union creates the GZ-69. Each of these vehicles traces its lineage to the simple American utility vehicle that German engineers examined in January 1945. The modern U.S. military Humvee, the Joint Light Tactical Vehicle, and countless civilian SUVs all descend from the same design philosophy: four-wheel drive, rugged construction, go-anywhere capability, simple maintenance. Müller himself survives the war. In 1946, American military government authorities find him working as a civilian mechanic in Stuttgart. They interview him about his wartime work. Asked about the Jeep evaluation, Müller is reflective. "We knew we were examining something important. The vehicle itself wasn't remarkable. Any competent engineer could design something similar. What was remarkable was that America built 600,000 of them. That's not engineering. That's industrial might." Asked if Germany could have built something comparable, he shakes his head. "We could have designed it. We couldn't have built it in those numbers. And building just a few thousand wouldn't have changed anything. The advantage came from building hundreds of thousands and equipping every unit, every function, every purpose. Germany never had that capacity." The American interviewer asks one final question. Did the Jeep win the war? Müller considers carefully before answering. No single weapon wins wars. But the Jeep allowed American forces to fight the way Americans fight. Fast, aggressive, with abundant supplies and quick response. It fit your military culture. You didn't need to conserve fuel or save your vehicles for critical moments. You just drove wherever you needed to go, knowing more Jeeps and more fuel were always available. That kind of warfare is only possible with overwhelming industrial production. The Jeep symbolized that production. Did it win the war? Did it help? Absolutely. The broader lesson. The story of German engineers examining a captured Jeep is ultimately about more than a single vehicle. It's about the relationship between industrial capacity and military effectiveness. Germany produced many excellent weapons: the MG-42 machine gun, the Tiger tank, the Me-262 jet fighter. Each was technically superior to American equivalents in some ways. But Germany couldn't produce them in sufficient numbers. America produced adequate weapons in overwhelming quantities. The Sherman tank wasn't as well armored as the Tiger, but America built 50,000 Shermans to Germany's 1,300 Tigers. The M1 Garand wasn't as controllable in automatic fire as the STG-44, but America equipped every infantryman with a semi-automatic rifle while Germany could barely supply one STG-44 per squad. The Jeep fits this pattern. It wasn't the world's best light vehicle. That distinction probably belonged to the German Schwimmwagen amphibious vehicle or perhaps the specialized British SAS Jeeps with their custom modifications. But it was good enough for nearly every purpose, simple enough for mass production, reliable enough for field maintenance, and produced in numbers that equipped the entire American military and supplied Allied forces as well. This philosophy, adequate equipment in overwhelming quantities, proved decisive. Wars aren't won by small numbers of excellent weapons. They're won by large numbers of adequate weapons employed by well-trained forces with effective doctrine and reliable logistics. The German engineers who examined the Jeep understood this. Their reports documented it clearly. But understanding the problem and having capacity to solve it are different things. By 1945, Germany could document American advantages but not match them. The industrial disparity was too great, the resource situation too dire, the strategic position too desperate. The Jeep, that simple 1,040-kilogram vehicle with its antiquated engine and crude construction, became a symbol of why Germany lost the war, not for lack of engineering skill or tactical competence, but because industrial capacity ultimately determines the outcome of total war. When German soldiers saw Jeeps racing across the battlefield, they weren't just seeing a vehicle. They were seeing the product of American factories that Germany couldn't bomb, supplied by resources Germany couldn't interdict, employed by forces that didn't need to conserve or ration or make do with limited equipment. Klaus Muller's report documented all of this in technical language and careful analysis. But the conclusion was simple: America could produce, Germany could not. And in the end, that made all the difference.